Next, I want to go to Earl Hackett. Earl, welcome.
Part 5.
Part 5, yes. We're going to talk about casting parts, using 3D printed parts to make molds for casting. And you may ask, why would you want to do that? Well, there's several reasons. One, you can use materials other than the gray plastic that comes with you get out of the printers. You can embed stuff in these things. You can use hard materials, soft materials, and you can color them too. So it's a whole range of things. And what we're going to be talking about is match plate patterns. It is the best way to build molds. Typically a match plate pattern is 2 parts, and it has indexes to make sure the 2 halves line up exactly. You can use stronger materials for the cast parts. You can make crystal clear castings to simulate window glass or lenses. You can embed stuff in the castings, and resin can be pigmented. Now, this is the old school. I used to make brass masters, put them in clay, build a box around them. Oh man, what a mess. It would take hours and hours and hours to clean that thing up so you can make the second mold. And these little tiny brackets here, I machined them in brass, and that's what convinced me I needed a digital readout. Now, here's an example of parts that were cast. I made the molds for these on my milling machine that was prior to the existence of 3D printing that was any good. But as you can see, these are, this is an epoxy resin. These were the heavy frames were cast in one part. And then we cast the sashes, the smaller red frames. And then in a third mold, the mold was designed so that I could set these sashes in the mold and then dump a clear epoxy on top of it, smooth it out, and you wound up with a, well, here's one here. You wound up with individual windows. The upper ones all could be opened, and these are all, the lower ones are all fixed. So how do you make a match plate pattern? Well, with 3D printing, it's very easy. You build your model, and you pick a plane, and you draw a plane, and you do what they call a split. Just split the model along that plane, move it apart, and insert a surface in between. You can see what you have here is another review of it. You include these registration pins. They're just cones, about a 60-degree angle. I find works pretty well. Notice that this cone here ends, this is the top of this cone. It's a truncated cone, and it's a little shorter than the one that it goes into so that you don't have any interference. Now these I produced with Shapeways FDP process. And you can see here it is in the mold box, but it hasn't been coated, right? Right here, you can see the frostiness of it. That tells me that I haven't sprayed it with a clear lacquer yet. If I put the rubber in there, it'd latch onto that thing and you'd never get it apart. It would be permanently, mechanically locked. Another view here, I've added a funnel. I thought this little thing was going to work, but it didn't, so I had to add a funnel to it. And you can see that the frostiness has gone away. It's been coated now with a high gloss finish. So you make the 2 halves and you pop them out, and this is what you wind up with. Now, these 2 molds, they fit together very nicely. What you're going to do is pour the resin into this funnel. It's going to go down here, run through this sprue, run along the mast, come up through the fittings into the signal head, and then exit out these vents. And there's a vent over here so you make sure you fill up the top of the mast as well. So in the steel mill or a metal foundry, this would be done in sand, and the sand itself is porous, so you don't have to worry about it. With silicone rubber, you have to vent for everything. This is the first test part that came out of the mold. That's how it came out of the mold. There is no flash. You don't have to clean up anything. That absolutely set me off. I almost fell over when I saw that. I said, that simplifies life so much. It's almost it's as good as anything you're going to get from an injection molding machine. So I'm building signals here. Going to put LEDs, and this is HO scale. And these little flecks of stuff here are light emitting diodes. They're 603 size diodes. It's a 0.6 of a millimeter by 0.3 of a millimeter. They are tiny little suckers. They're water sensitive, so I have some sodium hydroxide in here. When I close it up, it keeps the humidity at about 10%, so it stays fairly dry. But it's actually, it sounds difficult, but it isn't. You take a little circuit board like this, and you have to hand sand this thing down when circuit board shops can't make things this small. But all you do is put some drops of solder paste on there, and you set the little chip, little LED on it, and the solder paste is sort of sticky, so it holds it in position. And here's my high-tech soldering machine. Just take the thing, set it on this block of aluminum. This is this plain old electric hot plate running flat out at 450 Fahrenheit. The top of this thing gets up to 200, maybe 250. So you put it on there first to evaporate all the solvents in the solder paste. After about 10 or 15 seconds, you pick it up and you set it right on top of the heating element. You can see it really has discolored here a little bit. And after about 5 seconds, the solder melts, and the surface tension of the solder pulls those little things into exactly the right position. That you can see them wiggle on the giant line. You pick it up, set it aside, and it's done. It makes soldering very, very easy. It's a lot easier than doing through-hole soldering. So once you got them soldered, I'm going to put them in the mold. And the signal heads, CNO had an interesting arrangement. It was red, yellow, green, and then yellow, green, red. They wanted the two reds to be as far apart as possible. So I put them in there. The wires from them all track down to come out this vent, and this vent I packed with petroleum jelly. Put the other half on, and that's what comes out. Now this one here, you can see the wires all just come right down through here. They're all embedded. You can't see them. They're all hidden. So you don't have to worry about big blobs of wire running around and making your model look sort of bad. And then this mounts, this goes into a mounting box in the signal bridge. And I test everything. Every step of the way, I test to make sure that I haven't fried an LED. The way this one is designed, and I'm changing the design, if I fry one of these LEDs, you throw the thing away and start over. The new design will have pluggable signal head, so I can just plug a new head. If the LED gets fried, I just plug a new head in and I'm back in business again. This is just a little board that I can turn all the LEDs on and off here and just make sure they're all working. We can also do dwarfs. This is one of my old ones. This was done in a handmade mold. But again, you have those little LEDs sitting on a circuit board, and at the bottom of the circuit board is a 4-pin header that just plugs into a socket. Here's what one looks like when you cast it in a clear epoxy. Here's your circuit board, headers here, pins come out. You have another plug here, just hiding down below the ballast, and you plug it in and you're in business. I'm going to do it with 3D printing, and what I'll do is I'll just cast the lenses on it, and then mount the body of the 3D of the Dwarf around it, and cut off or sand away the extra circuit board material. And that's what it looks like when it's installed. The whole thing is scratch built. There's not a commercial part in there except for the LEDs. Casting is, you have to look at, it's really just a question of cost. If you're getting things from Shapeways, it's going to get fairly expensive. But if you're only going to make 2 or 3 of them, buy them from Shapeways. If you need 30 or 40 of them, It may well be worth your time. You could get an estimate of the cost of. You have to figure in the cost of the silicone rubber. A couple pounds of that will cost, $30. But you can go through $30 at Shapeways real quick. So anyway, there you go. You could use these things you don't have to use them just as a print. You can use them for making tools as well. Okay, the next time I'm going to show you some models that I've done. I'm finishing up my signal cabin. And if you were there last week, you saw me I showed how to build the little chimney. I couldn't believe how well that came out. I'll show it to you next week.